Hello, welcome back to ExamPadi. Today's topic is surds. In our previous lesson, we defined surds and differentiated between rational and irrational numbers. In today's lesson, I'll be taking us through the rules guiding the basic operations in surds. Two or more surds are said to be like surds if the number under the square root sign are the same. For example, root 2, 3 root 7 over root 5, root 3 over 5, and so on and so forth. Let's take a look at the rules. Rule number 1. In general, square root of AB can be written as root A times root B. This is also known as the product rule. For example, square root of 36 times 25 can be written as root 36 multiplied by root 25. And this can be written as root 6 would give us 6, root 25 would give us 5. 6 multiplied by 5 equals 30. We can also write this as root 36 times 25. Root 36 times 25 equals square root of 900. Square root of 900 would give us 30. The same answer but different rules, which means that square root of 36 times 25 is equals to root 36 times root 25. Rule number 2. In general, square root of A over square root of B is equal to square root of A over B. This is known as the division rule. For example, we have square root of 36 over square root of 9. This can be written as square root of 36 over 9. And this is equal to 6 over 3. 6 divided by 3, that is 2. So we can as well say square root of 36 over square root of 9 is equal to square root of 36 over 9. Rule number 3. This is the addition rule. Square root of A plus square root of B is not equals to square root of A plus B. Square root of A plus square root of B is not equals to square root of A plus B. For example, square root of 16 plus square root of 4 is not equals to square root of 16 plus 4. Rule number 4. Square root of A minus square root of B is not equals to square root of A minus B. That is, root 16 minus root 4 is not equals to square root of 16 minus 4. Rule number 5. Square root of A plus square root of A is equal to 2 root A. How? Root A is having a coefficient of 1. Also, this root A is having a coefficient of 1. Since they have the same coefficient, I can decide to add them together and pick one of these roots. 1 plus 1 is equals to 2. Then we have 2 root A. For example, if I have root 2 plus root 2, this is equal to 1 plus 1 into the bracket of root 2, which is equals to 2 root 2. Rule number 6. If I have root A minus root A, this is equal to 0. How? Root A is having a coefficient of 1. This root A also is having a coefficient of 1. So I have 1 minus 1 in brackets root A. 1 minus 1 will automatically give me 0. 0 multiplied by root A, that is 0. And rule number 7, which is the product rule. This says root A times root A is equal to root a square. When you have square root of a square, this square would cancel out, this square would cancel out the root. Therefore, we are left with a. Or you can also write it as square root of a square. According to the law of indices, we have a square raised to the power of 1 over 2. 2 would cancel out 2. We are left with a raised to the power of 1. Anything raised to the power of 1 is the same thing. So our answer here is a. For example, if you have root 4 times root 4, this can be written as square root of 4 square. And this is equals 4 square, open bracket, 1 over 2. 2 cancel out 2, and we have our answer to be 4. How do we add and subtract surds? To simplify a surd, where possible, express the number under the square root sign as a product of two factors, one of which is a perfect square. Note that like surds are surds that have the same number under the square root sign. For example, root a plus root a. In surds or roots, you can add or subtract like surds in the same manner as like terms in algebraic letters. Example 1 says 4 root 11 minus 2 root 11. In this case, since the roots are alike, that is, the two rational numbers are having the same root, I can write this as 4 minus 2 in a bracket root 11. 4 minus 2, that is 2 root 11. Example 2. 3 root 48 plus 192 plus 3 root 12. Now, solving this kind of question, you need to break down these roots into their simplest factors. For 48, we need to find two factors, one to be a perfect square, the other to be an imperfect or rational and irrational. While the same thing for 192, the same for 12. For 48, we can have the factors of 48 to be 16 multiplied by 3. For 192, we can have the factor to be 64 multiplied by 3. While for 12, we can have the factor to be 4 times 3. This can be written as 3 root 16 times root 3 plus root 64 times root 3 plus 3 times root 4 times root 3. So we have 3 times square root of 16 would give us 4 times root 3 plus square root of 64 would give us 8 times root 3 plus square root of 4 would give us 2 times root 3. Here we have 12 root 3 plus 8 root 3 plus 6 root 3. Since they all have the same root, I can add them together. 12 plus 8 plus 6 root 3. 12 plus 8 plus 6, that would give us 26. So we have 26 root 3. This is the answer. Let's take the third example, which is the combination of addition and subtraction of surds. We have 4 root 18 minus root 200 plus root 3 plus 3 root 50. So also we need to simplify this to their simplest form. So we have 4 root, this can be written as 9 times 8. While for 200 can be written as 100 times 2. And we have 3. 50 can be written as 25 multiplied by 2. Then we have 4 times root 9 would give us 3. And then we are left with root 2 minus root 100. That would give us 10. We are also left with root 2 plus 3 times root 25 would give us 5 times root 2. So we have 12 root 2 minus 10 root 2 plus 3 times 5, 15 root 2. So let's add and subtract since they have the same root. So we have 12 minus 10 plus 15, close bracket, root 2. 12 minus 10 is 2, 2 plus 15, that is 17. So we have 17 root 2. The next is the multiplication and division of surds. There are rules we need to take note of when multiplying and dividing surds. A. Simplify the surds if possible. B. Group the numbers together, coefficient of surds together, and then multiply. C. Simplify further if possible but divide surds. For example, you simplify the fraction if necessary. If the denominator has a surd, then rationalize. That is, to eliminate the surd in the denominator by multiplying both the numerator and the denominator of the fraction by the surd in the denominator. This will make the denominator a rational number. And lastly, simplify further if possible. Let's solve a few examples. 1. Square root of 24 times square root of 72 times 3 root 5. According to the rules we just read, we need to simplify each of these surds to their simplest form. Root 24 can be written as 4 times 6. Root 72 can be written as 36 times 2. And then we have 3 root 5. Square root of 4 would give us 2 times root 6 times square root of 36 would give us 6 root 2 times 3 root 5. Since we are dealing with multiplication, it is very easy for us to multiply each of the roots together. So we have 2 times 6 times 3 times a big root 6 times 2 times 5. 2 times 6 times 3, that would give us 36. 2 times 6 is 12 and 12 times 3 is 36. So we have 36 times the square root of 6 times 2 is 12. 12 times 5 is 60. So we have root 60. Now the question you are going to ask yourself is, can I simplify root 60 further? Yes, we can. So we have 36 times root 60 can be written as 4 times 15. And then we have 36 times square root of 4 is 2 times root 15. So we have 36 times 2, that is 72. So we have 72 root 15. That is our final answer. So let's take the last example, 2. We have 2 over root 11. So when we have a question like this, we are expected to rationalize. It's called rationalization. Rationalization simply means you are multiplying both the numerator and the denominator by the denominator. And that's exactly what we are going to do. So we have 2 over root 11 times root 11 over root 11. So we have 2 multiplied by root 11 to give us 2 root 11 over this 2 would give us 11 times 11, and this will be equals to 2 root 11 over square root of 121. 2 root 11 over square root of 121. That will be 2 root 11 over square root of 121 is 11, and our final answer is 2 root 11 over 11. We have come to the end of today's lesson. Answer the following questions to evaluate yourself. 1. Simplify root 2 times root 3 times root 5 times root 15 times root 20 times root 60. 2. Simplify square root of 162 minus open bracket root 2 close bracket raised to the power of 3. 3. Simplify 2 root 3 plus 2 root 2 all squared. And 4. Simplify 2 root 50 multiplied by 3 root 21 over 5 root 2 times 7 root 42. Thank you for learning about Surds Part 1B with me today. See you in our next video. Keep learning. Bye.